Alright, today's lesson is over how to use place value to add two decimal numbers. Should be pretty easy and straightforward. Go ahead and take a moment to copy down the focus question and then we will get started. Alright, so starting off, we've got Sally Jane and her friend Zeke. They're stopping at the Quick Shop to buy some snacks. They pick out a bag of pretzels for 89 cents and a bottle of cider for $1.97. At the checkout, clerk says that the computers are down, and then he calculates the bill himself. He writes down the numbers on a piece of paper, and he tells Sally Jane and Zeke that they owe $10.87 for their snacks, plus 66 cents more for tax. So obviously, if we add $1.97 to 89 cents, we shouldn't be getting $10.87. Most likely the clerk did not line up the decimal places. The most important thing about adding and subtracting decimals is that we line up the decimal place, because the decimal separates the large place values, the whole number place values, which will be on the left side of the decimal, from the smaller place values, which are on the right side of the decimal. Things like the tenths, the hundredths, and the thousandths, and so on, even smaller. So this would be how we would want to set up our addition. We would then want to add just like we normally would. So 9 plus 7 is 16. Write the 6, regroup the 1. 9 plus 8 is 17. Add in the extra 1. That'd be the 18. Carry the 1. Bring down our decimal. So the total for the snack should be $2.86, and then the tax would depend upon the $2.86, which of course should be a smaller amount, not 66 cents. The 66 cents would be based on the $10.87 and not the $2.87 or 86 cents. So in the next screen we see that Sally Jane pulls out her smartphone, adds up the numbers, and gets $2.86 before tax, thus verifying our previous addition on the earlier page. But she cannot convince the clerk that he's wrong. He simply will not accept that he is incorrect. So real quick, think about why the clerk might have arrived at $10.87. What could he have done? Is there a way that you could explain how the correct amount could not be $10.87? Is there a way that you could demonstrate that you are correct without saying the calculator says it's $2.86? Because sometimes the calculator could be wrong. Remember, the calculator is only as smart as the person poking the buttons, and sometimes humans make mistakes when poking calculator buttons. So go ahead, take a look, finish the rest of this, answer the next two questions, just think about them, move on. We're going to go on to another question, but I do want you to take time by looking at Sally Jane's estimation on her estimation of $3, and if that makes sense, and if that would be a good reason or a good way to justify to the clerk how his conclusion is incorrect. Alright, so the next thing we're going to do here is we are going to take a look at how to actually just apply estimation and adding to some real life problems. So the first thing we're going to do is we're going to look at this first problem here. This comes from your book. It is question E1. So we're going to rewrite the problem. First thing we're supposed to do is estimate the answers for each decimal sum. So what we're going to do here, E1. 1, we're going to round each number to the nearest, let's go ahead and round it to the nearest tenth. Okay, so 1.1999, or 1 and 1,999 10,000ths, is about 1 and 2/10. And then 2 and 200ths is pretty close to 2. Okay, So if I added these two numbers together, 1.2 plus 2, my answer should be about 3.2. Okay? So this is the estimation. Now, the real answer, if I take the time and add these up, so 1.1999 plus 2.02. And if you want, you can go ahead and fill in these numbers with extra places with zeros, not required with addition, but you should always do it if you are subtracting. We're going to go ahead and just add them together. So 9 plus 0 is 9, 9 plus 0 is 9, 9 plus 2 is 11, write the 1, carry the 1, 1 plus 1 is 2, bring down our decimals, remember we got to line those up, and then we get 3. Okay, so our real answer, the actual answer, is 3.2199. Our estimate was 3.2. The real one is 3.2199. 3 2/10 was our estimate. The actual answer is 3 2,199 10,000ths. A difference of only 199 10,000ths. So our estimate was very, very close. When estimating, it doesn't matter so long as you are rounding the number effectively to the same place value for both numbers. Let's go ahead and let's try E2, doing the same thing. We're gonna round E2. So we'll come down here, we'll do E2. E2 does the same thing. It says 1.762, okay, or 1 and 762 thousandths, and let's round that one to the nearest whole number this time, which means we're going to round it to this place. So that, we are going to look at the 7. The 7 is over halfway to the nearest whole number. 1 would push that to a 2, okay? And then 6 9/10 is close to 7. So we're going to say that our estimate would be 7 plus 2, which would be 9. The actual answer would be 1 and 762 thousandths plus 6 9/10. I'm going to go ahead and scroll down here a little bit. All right, add in those zeros. 2 plus 0 is 2, 6 plus 0 is 6, 9 and 7 is 16, bring down our decimal, go ahead and carry up our 1, and then we've got 6 plus 1 is 7, plus this 1 we carried is 8. And again, our answer is 8 and 662 thousandths, which is a difference of about 300 thousandths, which is not that significant. All right, go ahead and take a look at the rest of the problems if you want. Take a break, rewatch the video as many times as you need to, fast forward, rewind, pause, stop, whatever. I'll see you in class tomorrow.